Okay, so now we're on page 5 in the chapter 7 packet, and we're going to go over solving systems of equations through a method called elimination. Now, if you look at this system of equations, I want you to think about why you wouldn't want to solve this by first graphing and second by substitution. Now, we could solve by graphing. Graphing's not that hard, but you need graph paper and you need to be accurate and you need a ruler. And it's a good visual, but it's not the most accurate way to get an answer. So we don't always want to depend on graphing. Now, we wouldn't want to use substitution here because there are no coefficients that are 1. So that means if I was to solve for x in the first equation, I'd end up with a fraction, and nobody wants to substitute fractions. So this particular system, it's not convenient to solve through substitution, although it can be done. And it's not accurate to solve it through graphing, although it can be done. So we're going to use another method, and it's called the elimination method. Now, when you use the elimination method, the first thing you do is you always line up your variables and your constant. So if you want to think about putting it in a type of standard form, although A does not have to be positive. You see what I did here? I subtracted 2x from both sides, and now all my variables line up. So the first step in elimination is to always line up your variables and your constants. Now, notice, do you agree that negative 2x minus 9y equals negative 22? So negative 2x minus 9y is equivalent to negative 22. And the law of equations says I can add or subtract anything I want to my left-hand side as long as I do the equivalent to the right-hand side. So I'm going to add negative 2x plus 9y to the left-hand side of this equation, and I'm going to add negative 22 to the right-hand side. So look what happens when I do that. When I add 2x plus negative 2x, that becomes 0, goes away. When I add negative 9y to 5y, I get negative 4y. And when I add negative 22 to 6, I get negative 16. Now, divide by negative 4, divide by negative 4, and I get y equals 4. So I was able to eliminate the x's because by adding 2x and negative 2x together, they went away. Okay, this is the elimination method. Now, once I know y equals 4, I take either equation and I substitute 4 for y. And 2x plus 20 equals 6. 2x equals negative 14. X equals negative 7. So I end up with negative 7, 4 as an answer. Okay? And this is the elimination method. Now, if you look on page 5, you see I wrote down rules for elimination. So the rules for elimination say, rearrange equations so that the terms are in the same order. Look for coefficients that are the same. Ideally, we want coefficients that are the same number but opposite signs, because then we can just add the equations. Now, those of you who have never learned this method before, we're just always going to add equations. We're going to add the opposite. Anybody who's already learned this and wants to subtract, you may, but I'm not going to teach it that way. Okay, so let's look at example number 1. 4x minus 3y equals 11. 2x plus 3y equals 13. So now, first thing I do is make sure my variables and constants are in the same order, and they are. The x's above the x's, the y's are above the y's, and the constants above the constant. Now I look at the coefficients, and my ideal scenario is to have same coefficient, opposite sign. So I go, great. For the y's, I have same coefficient, opposite sign. That means if I add them together, I'll eliminate the y's. So I get 6x equals 24, x equals 4. Once I get x equals 4, I can plug it into either equation. So I'll do the top. 4 times 4 minus 3y equals 11. So subtract 16 from both sides. I get negative 3y equals negative 5. So y equals 5/3. So my ordered pair is 4, 5/3, which always I should mentally substitute back in and make sure I am correct. I am correct, so we don't have to do that. Okay, so now let's look at number 2. So number 2, negative 3x plus 4y equals 12. Negative 6y equals 18 minus 3x. So the first thing I do is rewrite these equations so variables line up and the constants line up. So I'm going to add 3x to both sides. 3x minus 6y equals 18. My other equation was negative 3x plus 4y equals 12. I see if I have any coefficients that are the same number, opposite sign, because that means they'll eliminate. So we eliminate the x's. We get negative 2y equals 30. Y equals negative 15. Then I just plug in negative 15 in either equation for y, and I get negative 3x equals 72, and x equals negative 24. So my ordered pair is negative 24, negative 15, which of course I mentally plug in to make sure it works. Okay, now let's look at number 3. Now, for number 3, we have 3a minus 4b equals 10. 3a plus 10b equals 24. Now, again, ideally, I'm looking for a situation where I have same coefficient, opposite sign. But I look here and I see, well, I have same coefficient, but it's the same sign. And I say to myself, oh, I really, really wish that bottom 3a was a negative 3a. I wonder if I have a magic wand that I can go, poof, you are a negative 3a. And guess what? I do. That magic wand is I can multiply both sides of my equation by negative 1. So I'm going to rewrite the first equation. But for the second equation, I'm going to multiply every term by negative 1. Now I'm like, yay, same coefficient, opposite sign. I eliminate the a's, so I get negative 14b equals negative 14, b equals negative 1. I plug in negative 1 for b. I get 3a plus 4 equals 10. 3a equals I'm doing something wrong. Oh, b equals positive 1. Did anybody notice I made a mistake with the sign? So this is a positive 1, so this should be minus 4. So 3a equals 14, a equals 14/3. So my answer here is 14/3, 1. Don't make sign errors, it messes everything up. Okay? So now I want everybody to try number 4 on your own. Stop the video, try to do it on your own, and then start the video and see how you did. Okay, so number 4, let's look at number 4. So we have negative 6x plus 16y equals negative 8. And 6x minus 42 equals 16y. Okay, so I first have to line up my variables because right now they're not lined up. So I'm going to keep the top equation the same, but for the bottom equation, I'm going to subtract 16y and add 42. Now, here, when I go to add them together, I go, uh-oh, my variable disappeared. Oh no, my variable disappeared. What happens when your variable disappears? That means you have to determine the truth value. Does 0 equal 34? And it does not, which means this is an example of no solution. Now let's think about why this is no solution. if we put these both into slope-intercept form, what do you think would happen? What would happen is we would realize we have parallel lines with the same slope but different y-intercepts. And we know that when lines have the same slope but different y-intercepts, they're parallel and they never intersect. Therefore, there's no solution. Okay, so the key to elimination is lining your variables up, x's over x's, y's over y's, constants over constants, and you look for a scenario where you have the same coefficient, opposite sign. If you have same coefficient, same sign, we just multiply one equation by -1, and then we add. Now, let's look at number 5. This says, find two numbers whose sum, x plus y equals 64, but whose difference, x minus y equals 42. Okay, now this is going to be so easy peasy to solve because I have a plus y minus y. I eliminate that and I get 2x equals 106. So x equals 53. And if I plug in 53, I find out the other one is 11. Okay, so once you know elimination, it's my favorite way of solving systems of equations. Okay, so you can stop the video now.